Okay, this is going to be page 341, 342. Toll booth collector estimates the 85% that go through the toll booth are cars and the other vehicles are not cars. So when we're looking at this, we're trying to figure out which ones are cars and which ones are not cars. All right. She uses 60 random numbers, 00 to 99, to show the next 60 cars that will drive through her toll booth. Which number could she have used to represent the two types of vehicles? Okay, what is the probability that it's not a car? So that means if it's 85%, then 0 through 84, those are all cars. So which numbers could she have used to represent the two types of vehicles? Okay, numbers 1 through 84 are cars. And 1 through 84, and then 85 to 99, because there's no 100 in here. 85 to 99 are other vehicles. Okay, so if it's 85 to 99 other vehicles, it says what is the experimental probability that the next vehicle is not a car? So that's this part right here. So we're going to have to do 99 minus 85, which equals 14. And if it equals 14, the probability of it not being a car all right, so 14 out of 99 is the probability that it's not a car. Right, because you got 60. Oh, it's 60 random numbers. Sorry, I was feeling confused. So if there's 60 random numbers, that is our probability. So if we've got 14, it's going to be 14 out of 60 is the probability, because 85 to 99, the difference between those is 14. Just making sure we're going to do 99 minus 85. 14. 14 out of 60. Okay, explain your answer. I subtracted numbers 85 to 99 and got 14, and there are 60 cars that have numbers. So when I'm going through and I'm circling, it says that you could choose which numbers here. I'm choosing any number that's over 85. 89, 86, 89, 96, 97, 96, 97, 91, 91, 94, and 98. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ah, that's why. So instead of subtracting, I need to actually look at the numbers on here. So this is why this is 11 out of 60. 11 out of 60, looking at the data. But, so it must be 14 out of 60 is the theoretical, and 11 out of 60 is experimental. All right, you spin a spinner with 4 equal sections. 4, A, B, C. Which statements are true? The theoretical probability that you land on A is twice C. That is true because look, you got 2 A's for every 1 C. The theoretical probability that you land on B is 1/4. Correct. The theoretical probability you land on A is 1/4. No, because that would be 2/4. Every time you perform an experiment, when you spin it 20 times, you will land on C 5 times. So 5 out of 20 needs to be equal to 1/4. Divide by 5, divide by 5. Would you spin the spinner 20 times? Oh, if you perform an experiment, they're trying to say that the theoretical and experimental. So this is theoretical, but experimentally we don't know that. So just A and B. Okay, on the back, we're on 342. There's a spinner. It has a number cube and the coin used to model. They have 4 equal sections labeled 1, 2, 2, and 3. The face on the number cube labeled 1, 1, 2, 2, 3, 3. So that one has 6 opportunities. On the coin, heads represents an even, tails is odd. So we're looking at how many odds and evens they have. Even number is the same with the spinner as the cube. Well, the spinner is 2, 4, 6. So that's 3 6 opportunity. And here it is 2/4 opportunity. Yeah, 2 out of 4, that would be even. And the spinner, the way that they have it, there's 1, 1, 2, 2, 3, 3. So there's 2 out of 6 here. So this has a 2 out of 6 opportunity. This has 2 out of 4, so that's false. Even number with the same is the same with the coin as with the spinner. Okay, so the coin, that's the theoretical. So 2, 4, 6 is 3 6, and this is 2 4. These are the same. 3 6 and 2 4 are the same because they could both equal 1/2. Odd number is the same with the coin as the spinner. So possibility of odd numbers is 2 out of 4. 2, 4, 6. Wait, 2 out of 4. And then the opportunity over here is 1, 3, 5. That would be 3 out of 6. So that's also true. But odd number with the coin and the cube is false because that would be 2 out of 6. So they're just reversed it on us. So false, true, true, false. Josh tracked the number of text messages he received in 1 week and the senders of those messages. He then did the same for a month. Used both sets of data to predict the number of text messages he will receive from his family in 1 year. So if we've got a week and then a month, we have to figure out the difference there and multiply the difference here. Then compare your prediction. Which prediction do you think is more accurate? So looking at how we would figure out the family for a year. The week was 13 out of, then we have to figure out the whole thing. So 13 over 8, 4. 13 over 48 is a week. A month is 60 over, we have to add all these up. $192. Okay. So it says compare their predictions. How much will he receive from his family in a year? For just the family. So this is kind of hard because you have to know how many weeks are in a year and how many months are in a year. So I will probably do month because month is times 12. A week, there's 52 weeks in a year. So we're going to have to multiply those by 52. So 13 times 52 equals 676 out of 48 times 52. 2,496. That's a week. A month, we're going to multiply by 12. 720. 192 times 12. It's 2,304. Okay, so when you compare these two, you're looking at how much you will probably receive. Well, based on a week, based on the week, he will receive 676 text messages. Based on the month, he will receive 720 text messages. Okay, the more accurate is actually the one that is on the month because it's a larger sample. So the month data is larger, and so it is more accurate. Remember we said the data that has like the most numbers is closer to the theoretical. Okay, and so that's going to be for 341 and 342.